Okay, here we go with a waves question. Really standard question for this one. Let's go for it. Okay, as ever, make sure you've done this question before you move on. Okay, and if you are looking at this kind of fresh, make sure that you are pausing and just sort of processing the question as we go, because I'm speaking quite fast. I'm aware of that. Okay, we've got a water wave transverse. Remember, we've got the disturbance, which is perpendicular to the energy direction of energy transfer. Figure 11.1, we're being asked to mark the amplitude and the wavelength. Now, again, the only problem you're going to have with this question, I think, is making sure that you read it carefully. Okay, you must do the labeling and do the things as they want. They want you to draw double-headed arrows, so you must draw double-headed arrows. They want you to label it with A and W. You must label it with A and W. You're not allowed to use anything else. Okay, so please, please, please just follow the instructions that you've got in front of you, because they do ignore anything else. Yeah. Wavelength is the distance from between corresponding points of the same wave and the neighboring wave. So, for example, peak to peak, or you could also draw trough to trough. That would be fine. Amplitude, again, I said another thing that could be confusing here is what the amplitude is. A lot of students tend to draw an arrow from the top to the bottom. It is not. It is the arrow from the middle to the top or middle to the bottom. All right, so make sure that you're drawing your arrow either beginning or ending at this central point. I've seen this question many times, so it's always a good one to bear in mind. Speaking of which, CIE's favourite equation is this one. Water wave has a wavelength of 0.078, and we're told the frequency of the wave, and we're being asked to calculate the wave speed. I've seen this come up in so many different papers. It's really repeated, and I think this is because in the waves topic there aren't many equations. So to be honest, I think I'm not making any guarantees at all, but just like electromagnetism, there's very few equations in there. You can usually predict the kinds of questions going to be asked. It's this one. We're going to use V equal F lambda. We know the wavelength, we know F, we multiply them, and we get a nice answer. This is such a nice question. Okay, I think I've said it before. If you are unsure about what to do with these numbers, you're either multiplying or dividing. Okay, so simply write down your process and go for it. V equal F lambda hopefully is an equation that you've got in your brain just through constant reusing, because it's a very, very common one. Okay, let's go down here. All right. Oh, here's another lovely standard question. We're being told about lenses refracting light. So you're asked to complete the ray diagram for the lens in figure 11.2 to show the location of the image formed, and draw the image formed with an arrow. So just like this. So here we've got our lens, and notice that our object is well outside the focal length. Okay, they've got the focal point here, principal focus on either side, and we're going to draw our object. We're going to have our object on this side, and we're going to draw our lines to try and form the image. So let's do that. Okay, we're going to firstly take our horizontal line parallel to the principal axis, and it's going to get to the middle of this lens, and it's going to then bend through the principal focus on the right hand side. We're then going to draw another line going right through, just not stopping, but it's got to pass through the center point of this lens. Those are the two lines you need to draw. You could draw another line which goes from here down to the focus and then out to the middle of the lens and then go horizontal, and it will cross at this point, but you don't need to draw it. CIE is very happy with just using two lines. Where those two guys meet is the image, so make sure you draw the image formed with an arrow. Okay. Now, why is that important? It's because you're then going to describe the characteristics of the image formed. Now, a lot of students don't know what we mean by characteristics. Characteristics means what type of image it is. So in this case, you'll notice that the arrow is upside down, it's very small, and it forms where the rays meet. In other words, it is real, forms where the rays meet. It is inverted, which means it's upside down, and it is diminished, which is small. Now notice it's a 2-mark question. I didn't need to give 3 things here, but I did purely to give you the options of choosing whichever ones you think are most obvious to you. Okay, last one then. And this is a nice, I quite like this question. We've got sun transferring energy via infrared waves to the Earth. We've got the Earth emits infrared radiation to space. To state and explain what happens to the temperature of the Earth during the daytime and during the nighttime. Okay, well, in the daytime, you should be aware that the temperature of the Earth increases due to the absorption of infrared radiation. Okay, key point here is it's not due to light. A lot of students think that light is the thing that's causing us to be heated up. Light is the partner to the infrared radiation. It appears at the same time as the infrared radiation. However, it is not the thing that's heating us up. It's coming along with it. Okay. At nighttime, it's similar. We don't have any incoming infrared radiation. However, we still have outgoing radiation. Okay. And so maybe what I need to add to my answer here is that in the daytime, we are absorb more than we emit. And in the nighttime, we emit more than we absorb. And that probably is what I should be adding here to make this a fully complete answer. But I didn't. Okay. So yeah, in your exams, give as much as you can. You see that 3 marks, add a bit more in just to make sure that your answer is as complete as possible.